Hi folks, welcome back. In the previous video, we talked about setting up, manage cloud service mesh on GKE. We also, installed the gateway and how to use, how to expose a particular microservice using the gateway and virtual service. All those things we have discussed. So all those stuffs, whatever we discussed, that was, for a particular GKE cluster where you have implemented all those things. Let's think about a scenario where you have multiple GKE clusters which are running on a particular project. So how we can, or it could be on a different project as well. So suppose like but the cluster A is running on project A and cluster B is running on project B. Even those can also be a part of the single fleet. That's what we have learned in our earlier videos. So now how we can create these multi-cluster managed cloud service mesh on GKE. So that is what we are going to learn in this particular video. So let's try to set up this multi-cluster service mesh on the managed GKE stuff. So without wasting the time, let's go to the instructions. So the prerequisite is we need to have two or more GKE clusters. It could be part of the single project or it could be part of the multiple project. So in my scenario, what I have done in a particular project, so I have created two GKE clusters and I have ensured that both of these GKE clusters are created in a different subnet and particularly in a different region. So in order to give the full visibility or the actual implementation, whatever you're going to do in the production, so I have tried to come up with this multi-cloud cloud service mesh, which is managed one on the GKE. I ensured that these are in different regions and they are in different subnets as well. So the prerequisite is, of course, you need to have two different GKE clusters and you need to have the GKE cloud service mesh installed on that, which should be a managed one. Of course, for the GKE, as I said, Google completely recommends to have the managed service mesh. You can do in cluster service mesh. However, GKE doesn't recommend that. So that is the reason why we are installing the managed GKE service mesh. So let's go and spin up to GKE clusters. This is my console. So okay, before that, what I have done, let me go to VPC. So I have created a new VPC. Okay, this is my new VPC. I'm not using the default VPC. This is my new VPC, and I have created two subnets. One is in US Central one, another one is US East one. And at the firewall level, the default firewall rules, whatever it creates, so I have just leveraged those. So this is the one. ICMP protocol, I have allowed TCP and SSH, I mean sorry, the TCP at the port 22. And apart from that, the only change what I have done is for this custom, I mean, it's just a default one only. By default, it allows for universe 0.0.0.0. So what I have done, rather than that source filter, I have given only for this, and the protocols for TCP, UDP, and ICP I have restricted only for this. That's all. I mean, this is very straightforward. So now, if you go to Kubernetes, let's create two Kubernetes clusters in two different regions. All right, let me create my first cluster. So I have already demonstrated in my previous videos. In case if you have missed my previous videos, I would recommend you to go and watch that. However, here as well I am doing it from the scratch, but it's always good to go back there and see from the scratch because I have explained so many other things there. So I'll keep my cluster name as cluster 1 only. I would be creating one cluster in US Central 1 because I have my subnet spread across US Central 1 and US East 1. So the node location, I would be choosing 3 because I would be creating 3 worker nodes. I'll use regular channel, I'll keep the same version. It's my standard cluster, not the enterprise cluster. Fleet registration I'm not doing now. I'm doing it together later. So I am leveraging the default pool only. and number of nodes per zone I'll keep only one, so that total number of nodes in the cluster would be 3. And then node search and let it be the default. I'm not changing it. And then if I go to automation section, so here again I am not changing anything, I'm keeping as it is. And here in the networking section, so rather than default VPC, I will be leveraging the VPC which I have created. So here I'm using mesh central 1, and then I would be keeping all these default settings as it is. I'm enabling data plan v2, HTTP load balancer. This is required for gateway and other stuffs, so I keep it enabled. That's all under the networking section. If you go to security section, here I don't want shielded. I need workload entity. If you remember, I mean, if you have watched my previous videos, I have stressed on this particular point that workload entity is mandatory for enabling, uh, you know, a fleet enabled cluster or fleet managed clusters. I'll be disabling this. I don't need that. And then in the metadata section, I would be keeping everything as it is. Now if I come back to my default node pool here in the node section, let it be COS, E2 medium only, and I don't need 100 GB. Why should I need that much? This is for testing purpose. All right, in the automation, everything is sorted. Networking, everything is sorted. Security is done. I don't need any backup plan. Metadata I don't need. Features I don't need any logging enabled. So here as well I exclude my workload as well. Okay, and then that's all. Let it be the CSI driver. So that's it. Let me create my first cluster. Why it's showing 160 when I already disabled the logging. Oh, okay. Number of nodes are increased. Oh, all right. That's good. So we are good now. Features wise, I have disabled. Let me create the first cluster. All right. So let's create one more cluster parallelly. So this would be cluster 2. Let it be the same. Now in this case, I'll be creating it in US East 1 location. Again, I will be creating 3 worker nodes, and that's it here. Fleet registration I'm not doing now. I'll do it later. I will be again using the default pool only. Number of nodes per zone would be 1. So total number of clusters this cluster runs is 3. Then that's it. Nodes. I would be reducing the boot disk size from 100 GB to 50 GB. Networking. Here I'm not going to change anything. Security. I don't need any integrity monitoring. Metadata. I don't touch it. Automation, everything I keep it as it is. I don't touch that. Here I will be using my mesh VPC, and in this case I'm using the mesh east subnet which is created in US East 1 location. So this also I'll keep as it is. I'm not touching it anything. I'm just enabling the data plane v2, HTTP load balancing. In the security section I'll remove the security pasture. However, I will be enabling the workload entity, which is mandatory. I would be again removing the shielding option. Backup plan I don't need. Metadata I don't need. Features wise, I will be disabling the logging. That's good. So let's go and create this. So let's wait until this clusters completely create, and then we'll come back. All right, now the clusters are completely created. So let's go to my command line and get the credentials for those cluster. For simplicity, I have made my commands list here just to save the time. So this would be listing, the clusters which are created in this particular project. So now what I'll do, I'll enable, I mean, if you watched my previous videos, I have already demonstrated, step-by-step process to enable the managed service mesh on the GKE. So same thing I would be repeating. This command will enable the mesh service at the project level. Now, basically, now what I will do, I will register my first cluster to the fleet. Let's go back to all fleets and see. If you see here, currently there are no fleets. If we register our first cluster to fleet successfully, then it would automatically create the fleet as well. There you go. You have your cluster registered to fleet, which is, our cluster 1, which is in US Central 1 location. So now let's do the same thing for my other cluster, which is in ES East 1 location. There you go. It registered my second cluster as well. You can always go back and see this in the command line as well. Okay, so we have our fleet enabled for, I mean, we have enabled the fleet for our GKE, and then we have registered both our cluster 1 and cluster 2 to fleet. So now what we will do is we'll enable the managed service mesh for both the clusters one by one. So this would be enabling my managed service mesh. That means both control plane and data plane would be managed by Google. That is for my first project, which is running in US Central 1 location. So this should be fast. Same thing let's do for second cluster. All right, so now that it is enabled, it would take from a minute to maximum 10 minutes to completely enable the service mesh on your clusters. Usually it would be fast if you followed all the prerequisite properly. So in my case, I assume I followed everything properly. So it shouldn't take more than 2 to 3 minutes. So let's come back once it is completely enabled. Okay, so now that it is installed, if you see here one by one, so for cluster 1, if you see management automatic, cluster 2 management automatic. So cluster 1, my control plane is ready and active, and my data plane is active as well. Similarly, for my cluster 2, control plane and data plane is active. That means we have successfully installed the cloud service mesh, which is a managed cloud service mesh, both on cluster 1 and cluster 2, which is created in two different regions and two different subnet. All right. So now if we go back to the documentation, there you go. Here it is. So in the previous scenario, I mean the previous video, what we have done, we have enabled service mesh and the GKE that will demonstrate the process for the one cluster. Now, if you come back here under the operate and maintain, so this is the the document section. There it is mentioned the instructions to set up the multi-cluster mesh and GKE, which is a managed GKE. So what I have done for saving the time, I have edited this variable with whatever my project details and all. So let's quickly do. So let's quickly see what exactly it is doing. All it is doing is I'm exporting. I mean I'm exporting my project location, the cluster name. So using which it is just generating one context kind of thing for simplicity. So similarly, my project 2, which would be generating the context. So now I will fetch my credentials both for cluster 1 and cluster 2 to access the cluster. Now, since your clusters are in two different subnets, you need to create this firewall rule. All this firewall rule does is it combines the CIDR range for your network into one common firewall rule so that you can allow the traffic and you can enable the communication between two different subnets. So in my case, this is the one. So that's the thing. Now this is the I mean this is the command to extract those particular pod CIDR range and the IP tags for that, basically the node tags for that. And in the next step I would be creating this firewall rule which is necessary for that. So in case of manage service mesh, the only method or the simplest method or the easiest method I can say is just enable the cluster endpoint discovery. That is the stuff. That's it. I mean it would be automatically able to communicate. So in our case, all we are doing is since we have already installed the cloud service mesh, we would be seeing a config map called ASM options under the istio system namespace. So we just need to go and update it as a multi-cluster mode as connected. So in our case, what happened is now with most of the cases, cloud service mesh, when you install the managed cloud service mesh, automatically this section is enabled. So you need to be little bit watchful or mindful on what you do. So you need to always check this whether it is already enabled or not. If it is enabled, you need not to do anything, just skip this step. If it is not enabled, just you need to run this so that the multi-cluster mode will be activated on that particular cluster. So that's it. And what it does is it creates a secret, which is basically a remote secret to establish the communication for the second cluster. Second cluster would refer that. Similarly, in the other cluster, whenever you create, the first cluster would refer that, vice versa. So now the only way to verify the connectivity of this multi-cluster is create one sample deployment and expose the service and see that it is successfully done. There is some kind of I can say this document contains some kind of a data which is quite misleading. It's not up to date, I can say, because this section whatever it is mentioned here is the quite legacy one. It would be referring to old ASM, but actually that is not present here. So that is why they have put it under the notes section here. The samples are presented inside this Git repo, which anyway, during the demonstration, I will explain. So these steps won't work if you are trying, are following the documentation as it is. So the samples, stuffs, deployment, services, everything is present in this particular folder. So after that, I would be creating a namespace called sample and both the clusters, and then I would be doing the istio injection, and then I will create a service for both clusters, and then I would be deploying the particular hello world application version v1 on cluster 1, version v2 on cluster 2, and then I would be artificially generating a load with the help of the sleep service. So what I will do, rather than generating this load on both the clusters, for better understanding purpose, I would be generating this load only on one particular cluster, and then let's try to see how this load is distributed on both the clusters. That we can always go back and watch here whether the load is transferring to other service or not. So that way, once you see that load is transferred to both the cluster, you would be seeing, it is generating from V2 and V1 and all. That shows that even though, this load, I mean, since your applications are running on both the clusters, when the load is extreme, the load automatically, because of this multi-cluster stuff, automatically the load will be transferred to other cluster and it would be serving from that particular microservice running on second cluster. So that's a beautiful thing, So let's see and install that and practically demonstrate it. So let's go back to the top and run these stuffs. Now I would be getting the cluster context. So let me see whether I got the context or not. My bad. Okay, we have fetched the kube config details for both the clusters. So currently the context is set to cluster 2. So let's see if I'm able to access that cluster or not. Well, I am. Now what I will do, I will switch to cluster 1 and see if I'm able to access that or not. Well, I am. So that's good. So now we have fetched the kubeconfig file for both the clusters, and then we have tried to access the clusters and ensured that both the clusters are accessible. So now let's run this command to get the CIDR ranges and network tags for both the clusters. All right, so if you want to see this, you can always go back and see the network tags. These are the cluster network tags, and then your CIDRs as well. You can go and see. There you go. Okay, we are good now. Now let's create this firewall rule. So let's go to the UI and see. Let's go to Mesh VPC, firewall. There you go. It's creating this rule and then the IP range, this protocols. That's what this command, is creating. So now let's go back to the documentation. Now let's see this option. So, okay, where I am now, kubectl config current context. Okay, I'm in cluster 1 now. Now, if you see, when you have enabled the service mesh, you would be getting this namespace. Now, what I will do, I will list the config map and secrets which are running in Istio system namespace. Okay, the one which I'm interested would be this. So now let me try to list this config map. So this is the one. If you see here, it is already multi-cluster mode is connected. if you see that this option is not there, now all this command does is it just does the patching for this config map and it adds this section. That's it. And in some cases, if you see that this config map itself doesn't exist, then you can always go back and run this command. It will create that config map and then it adds the data section. So for security reasons, I'm not opening this config map. I mean the secret. You can always go back and open the secret. Since I'm in cluster 1, you are seeing the secret for cluster 2. Similarly, in the cluster 2, you will be seeing the secret for cluster 1, which is a remote secret. And with the help of that, it will establish the communication. Anyway, we can always go back and see that. So what I will do, I will switch my context to cluster 2. Sorry. kubectl config get context kubectl config context. This is my second cluster. So if I list, you would be seeing the same. There you go. That's what I meant. So we are good here. So now let's go further, and here is the place where you have a repository, and here you have all the working examples. So inside this istio samples directory, you have so many subdirectories. So here hello world example is the one which we are using. So yeah, I mean you can go back. I mean you can always go and see here hello world.yaml. So this is a service. Okay, hello world service. And if you see here deployment, we have version v1, we have version v2. Okay, so similarly there is one more sleep command. So this is the sleep command which just artificially generates the load. What it does is this uses this curl image and then just indefinitely runs this sleep for a particular amount of time. Indefinite command, I think. Yeah. So that's it. Then what else is there? If you want to expose this via gateway and see, yeah, in my example, I would not be demonstrating this because I will be recording one more video on multi-cluster ingress and multi-cluster service. At that time, we will be creating two different clusters and we'll deploy the common microservice in both the application. And but we will be ensuring that some of the applications are running only on cluster 1 and some of the applications running only on the cluster 2. Then with the help of this service, how this multi-cluster ingress and multi-cluster gateway works, that would be a separate video I would be recording in the upcoming sessions. So that is the reason why I'm not creating any gateway here to demonstrate it. I'm just explaining the multi-cluster service, multi-cluster service mesh just with one simple example, which is a hello world example. So I I have already cloned this repository in my local. So I would be going inside this. So if you see, I have everything present here. So okay, good. Now let's go back. So as I said, don't worry about this, ignore this. Now what I will do, yeah. So I will just my sample directory, I will set it to uh, Istio. Istio is the place where all these files are present. That is what I am setting. In this case, they earlier, I think, when you run the asmcli command in the output directory, you will give whatever the output directory command. That is what they're referencing here. Since I'm not used asmcli in this case, so I have cloned the repository which they have given here. So that is the one which I have given here. I mean the base directory, which is Istio directory itself. So now this simple for loop, what it does is for every cluster, it means both it will iterate through both of my clusters, and then It will, using that particular context, then it will create a simple namespace called sample, and inside that sample, it will do the istio injection. So let's quickly do that. I think I'm in cluster 2, so let me see in the cluster 2 it's created or not. If it's created in cluster 2, it should have been definitely created. Yeah, there you go. It should have been definitely created in cluster 1 as well. So the next step would be revision, which is HTO injection. There you go. Now what I will do, kubectl get ns hyphen hyphen show labels. So the namespace would be sample, yeah, sample only. Oh, label spelling is wrong. So let's see. Okay, we have the istio injection enabled for this. Now whatever the resource you create inside this particular namespace will inherit this automatically. So okay, here you go. Now what I will do, I'll just create the uh, service here. If you see, that is the reason why I'm using the label here. So if you go to that example, it has a label for each. So I'm not doing everything at once. So I'm just creating. If you see in the label, I have given two labels here. I mean, sorry, not me, it's the Google. So they have given two labels here. So service hello world and app hello world. So I would be leveraging this and demonstrating, I mean, deploying it. So where is the example? This is the example. So with the help of that, it just creates a service, nothing much to start with. Okay, it now switch to first cluster and it created the service. Okay, now similarly, it will switch to second cluster and create a service. We can, since we are in cluster 2, we can go and see that. So when you do kubectl get all hyphen n sample, it will show that it has created just a service. Okay, that's good. Now what we will do is we will deploy the version 1, okay, the deployment version 1 in cluster 1, version 2 in cluster 2, again with the help of labels. Version v2 is the label, here version v1 is the label. This is very handy, if you go, I mean, if you have already done the blue-green deployment, you would be always knowing these concepts of versions, how we can leverage. What wrong I have done? Oh, sorry, wrong command. V1, I have wrongly copied something else. My bad. Okay, now I'm in cluster 2. Let me go and see. Yeah, it is initializing. Deployment V2. Let's wait. Pod is getting initialized. Let's give, now let's verify whether it's successfully installed in the cluster 1. There you go, it is successfully installed. Now let's go to cluster 2 and see it is installed in the cluster 2 as well. So now what I'll do, I'll not run this on every cluster. I would be running this only on one cluster. So what I will do, I'll just remove this CTR2, or let me, since I'm in cluster 2, let me run only on cluster 2 the sleep command and see whether the load will be spreaded to cluster 1 or not. So now if you see the cluster 2, you should see the sleep command as well, which will start generating a lot of load because it constantly does the curl. Okay, now the sleep is running. Now let's go back and see the cross cluster load balancing. Now what I will do, okay, this might not work because I'm running only in the C2. Now let me run this one. Let's see. Ah, there you go. If you see once it's calling, V1 and it's calling V2, it's calling V1, V2. That means even though your service, which is, sleep service is running here itself, because it is generating a lot of loads, sometimes it's sending the traffic to version v1 and sometimes sending the traffic to version v2. How simple it is. This is just, I have demonstrated with simple example. In the later sessions, we would be picking up the complex microservices. There are beautiful examples which is present in Anthos Service Mesh example repository. Maybe we will pick it up on a boutique example that contains end-to-end architecture, front end, back end, database, everything it has. So in the upcoming session, when I demonstrate the complete implementation end-to-end, in that example, I would be explaining it with one complex microservice. So here in this, session, we our idea was to, set up a multi-cluster mesh, which is a managed cloud service mesh, and then how, we can ensure that these are connected and the load is transferred across the cluster. That we have demonstrated with the help of example. So in the upcoming session, let's try to install the cloud service mesh on of Google Cloud environments, and again the multi-cluster service mesh for off Google Cloud, which could be, your GKE in Azure, GKE in Amazon, or even the attached clusters. And then we even further explore about this MCS, which is multi-cluster service, multi-cluster mesh. I mean multi-cluster gateways. All those things, we will explore in upcoming session. So stay tuned and please subscribe to my channel and support me. Thank you, friends.